Hi class, great morning, and thanks Mrs. Lowe for being here today. Today we're going to be doing 6.2b lesson, the Pythagorean Theorem and unknown side lengths. So please turn to page 32 if you're not there already. I'm on page 32. Are you on page 32? So yesterday we discussed the Pythagorean Theorem a little bit, and we saw that for what type of triangle? That's right, for any right triangle, we saw that the area of a square created on a leg plus the area of the square created on the other leg is equal to the square created with the hypotenuse. And that's how we make the Pythagorean theorem, which is a squared plus b squared equals c squared. Meaning for any right triangle with leg lengths a and b and hypotenuse length c, a squared plus b squared equals c squared. That leads us into number 1, which tells you to provide an example and define the Pythagorean theorem. 3 minutes with your group. Go ahead. I hope in your definition that you talked about it having to be a right triangle with leg lengths a, b, and hypotenuse length c to make a squared plus b squared equals c squared. My example is I gave a right triangle with leg lengths 8 and 6, and I showed that when I solved, I have a c length of 10. So my hypotenuse would be length 10. Let's continue. Draw an arrow from the right angle to the hypotenuse. Find the length of the hypotenuse using the Pythagorean theorem. Leave your answer in simplest radical form and show all of your work. So taking a look, something that I told you is going to be helpful is that whenever you see a right triangle is to draw an arrow from the right angle to the hypotenuse. That's because sometimes we're going to be looking for the hypotenuse length and sometimes we're going to be looking for a leg length. Let's do one of these together. Taking a look at number 2, the first thing I'm going to do is see that I'm missing my leg lengths and I'm asked for my hypotenuse. So writing the Pythagorean theorem, a squared plus b squared equals c squared. Does it matter if 9 is my a value or my b value? No, it doesn't. It's just a leg value. So I'm going to have 9 squared. If I use 9 for a, I have to use 12 for b. And I'm going to be solving for c. 9 squared is, that's right, 81. 12 squared is, that's right, 144. And that's going to be set equal to my c squared. When I add 81 and 144, I get 225 equals c squared. But I don't want to know what c squared is, I want to know what c is. How do I undo squaring? That's right, take the square root. So I know c is equal to the square root of 225, which if you have your perfect squares memorized, that is equal to 15. So c is equal to 15 here. I would like you to do number 3 and 4 with your group, and I'm going to give you 4 minutes. Please put 4 minutes on the timer and pause the video now. Awesome, let's see how you did. Taking a look at number 3, did you remember to leave your answer in simplest radical form? When I'm looking at number 3, I saw that I had 6 and 2 as my leg lengths. So after I squared and added, you should have had c squared equals 40. Now, to get c by itself, I take the square root of both sides. And I notice that 40 has a perfect square factor. What's a perfect square factor of 40? That's right, it's 4. 40, radical 40 is radical 4 times radical 10, and radical 4 is equal to 2, so I know that c is equal to 2 radical 10. If you wrote it as radical 40, please simplify your answer. Remember, radicals are simplified when the greatest perfect square factor is 1. Looking at number 4, please don't be afraid of those decimals. When we square using our calculator, we see that 0.64 and 0.36 is equal to c squared, but when you add those, you just get 1. If 1 is equal to c squared, I take the square root of both sides, and what times itself equals 1? Just 1, so c is equal to 1. Wonderful. Let's make this a little bit harder. Start reading the directions for 5, 6, and 7 as I read them to you. Please track using your pen, finger, eyeballs, something on your paper as I read the directions to you. Find the missing length for each right triangle shown below using the Pythagorean theorem. Leave your answer in simplest radical form. Show all your work. So now it's going to be really important for us to identify the hypotenuse. How do we do that? Draw an arrow from your right angle. Good job. This way, we'll make sure to be solving this correctly. So taking a look at 5, 6, and 7, I am going to do 6 with you. Looking at 6, I notice that I'm given my hypotenuse, but I don't know my leg length. So I'm going to write the Pythagorean theorem, a squared plus b squared equals c squared. I know my c value is 12. Does it matter if 8 is my a or b value? No, it doesn't. So I'm going to make it my a value. And you can leave your b value as b or write it as x, whichever you prefer. So now 8 squared is 64 plus b squared equals 12 squared is, that's right, 144. I need to solve for b squared, so I have to get rid of the 64 first. What do? Subtract 64 from both sides. When I do that, I end up with b squared is equal to 80. But I don't want b squared, I just want b. So let's take the square root of both sides. Excellent. So I know that b is equal to radical 80. You can make a factor tree here, or you can just think of a perfect square that goes into 80. If I make a factor tree with 80, I know, what's the first factor you think of that goes into 80? 8 and 10. Me too. And from 10, 4 and 2, and 10, 5 and 2, and 4 is 2 and 2. So I have 2, 2, 2, 5, and 2. So b is equal to radical 2 squared, 2 squared, and 5. What can I pull out of my radical? A 2 and another 2. Those are the terms being squared, and the 5 is left inside. Numbers on the outside are being multiplied by each other, so that's 4 radical 5. So I know my x value here is 4 radical 5. Let's do number 7 together. Looking at number 7, I have some fractions here. So when I'm looking at number 7, I drew my arrow and I know my c value. So let's write my Pythagorean theorem, a squared plus b squared equals c squared. My a value is, let's make it 3/4. If you made it 1/2, that's fine. My b value then is 1/2 being squared equals c squared. 3/4 squared is 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. You guys, I made a mistake. Notice 3/4 was that's right, my c value. Silly Mrs. Barr. I hope you caught my mistake as well. So let's take a look. Let's restart this problem. And if you don't have room, you can always go to your opposite page. A squared plus b squared equals c squared. So sometimes it's helpful to even write the variables next to the numbers so we don't make silly mistakes like that. So 1/2 squared plus, I'm going to have it my b squared, equals my c squared, which is 3/4. 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. Plus b squared. 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. If I'm going to be solving for b, I need to subtract a quarter from both sides. Notice if I'm subtracting fractions, I need that's right, a common denominator. So 16 is my common denominator. So if I have a common denominator of 16, this is really 4/16. 1/4 minus 1/4 gets me nothing, 0. B squared equals 9/16 minus 4/16 is 5/16. But I don't want b squared, I just want b. So what do I do to both sides? Take the square root. So b is equal to the square root of 5 over the square root of 16. Square root of 5 is in simplest radical form, and the square root of 16 is 4. So I know my b value is radical 5 over 4. Or my x value, as they called it. Excellent. I would like you to do number 5. And on the next page, number 12. 5 and 12. 5 and 12, and I'm going to give you 4 minutes. 5 and 12 in 4 minutes. Please pause the video now. Let's see how we did. Number 5, you should have gotten your b value to be 7. Take a look at the work and remember this is also available online. We end up with b squared equals 49. Take the square root of both sides and we get 7. Now let's go and look at number 12, which you just did. Did you get a number and a radical when you wrote it in simplest radical form? Number 12, the answer is 10 radical 2. So number 12, notice that x and x squared plus x squared is 2x squared. So I have to divide both sides by 2 to get x squared equals 200. Then take the square root of 200, which I know 200 is 100 times 2. The square root of 100 is 10, and the 2 stays inside. So 10 radical 2. We're going to do number 9 together. We're going to do number 9 together, and you're going to do 10 and 13 on your own. So let's look at number 9. Let's draw our arrow so we don't make any silly mistakes. So we know that our missing length is a leg, and they say it's a. So when I write my Pythagorean theorem, a squared plus b squared equals c squared, and again, if you need more room, please move to your opposite page. I know that my c value is 4 radical 10. Please use your parentheses. My a value is unknown. And my b value is 2 radical 5. To square these numbers, I want to bring the number on the outside back into the inside. What do I have to do to the number on the inside of the radical to bring it back inside? That's right, I have to square it. So I'm going to have a squared plus 2 squared is 4, and 4 times 5 is 20. So this is radical 20 being squared. Equals, to bring the 4 back inside, I have to square it. 4 squared is 16, and 16 times 10 is 160. A squared. Remember, squaring and square roots undo each other, so this is a squared plus 20 equals 160. Well, that looks a lot easier to solve. Let's subtract 20 from both sides to get a squared equals 140. Now to solve, I'm going to take the square root of both sides to get my a value by itself. When I do that, I now have a is equal to radical 140. I bet there's a perfect square factor that goes into 140. Let's look at a factor tree for 140. 140 is 14 times 10, and 14 is 7 times 2, and 10 is 2 times 5. So I know when I